Hi, my name is Ben, and I'm a Master Peer Instructor at the Hive. Today, we will be going through a series of instructional videos on how to use the PCB fabrication equipment. The first step is going to be to log into the tools. Use your buzz card and tap it on the reader next to the kiosk. Make sure you're logged in as a general user, and then log into both the PCB plotter and the PCB laser. These will turn on the monitors for the respective tools. The software should already be loaded for your use. So the first thing you're going to do after you log in is turn the tool on. The main switch is located underneath the cover to the right above the main power line. You go ahead and turn that on. You'll hear the vacuum system turn on, as well as the main red light. It lights up the camera. Go ahead and close the main cover, and we'll start the software. The software is called LPKF Circuit Pro. It's located both on the desktop here, as well as on the main toolbar at the bottom. When you load it, it can take a few minutes to load. The first thing that it will do is connect to the system. It will read in some settings and reference itself, as well as turn on the main camera. While the ProtoMat software is starting up, you can go ahead and warm up the laser. The laser takes 20 minutes to warm up, so it's a good idea to start this at this time. To turn the proto laser on, simply press the power button down here. Do not press the emergency stop button. This big red button is only to be pressed in case of fire. The machine may beep at you, it may complain about all kinds of things, but unless there is fire, do not press this button. It will cause the machine to be down for an indeterminate period of time while we reset everything. So please, do not press this button unless there is fire. To turn on the machine, though, one press will turn it on. The computer is actually located in the tool itself, so there's no computer to turn on, and the monitor is controlled through sums. So as long as you have logged in, the monitor will turn on as well. Once the desktop has booted up, you can go ahead and start the software. The software is called LPKF Circuit Pro and is located both on the desktop as well as on the main toolbar. Simply click once to load it. The software will take a few minutes to load. It needs to reference itself to the machine and confirm connections and settings and various other internal self-tests. It will ask if all the status lights are on. If they are, go ahead and hit yes. Red is indicative that the laser or the motor is non-functional at that time. This can be either because the door is open or for a fatal laser error. Green indicates that the laser is good to go. In our case, since all the lights are lit, go ahead and click yes. The proto laser requires a 20-minute warm-up time before it can be used every time it is turned on. To begin this warm-up period, first select any template by loading the template in the lower right corner. Click OK through Material Settings, and then press the red laser button in the main toolbar to begin the warm-up. Once the warm-up has begun, you may begin your process at the ProtoMat. Once the tool has started up and has been referenced by the software, the new document window will open. The new document window has two tabs. The left tab, the Projects tab, shows a list of recent projects, only 5 of them, from which you can start one of your previously done projects. This is extremely valuable if the software closed unexpectedly for some reason or something similar, or you had to leave for whatever reason. The right tab shows a number of different predefined templates that you can select from as well. We're not going to be dealing with any of these today. Instead, from the Projects tab, simply select Load Default Template on the lower left to continue. The software has two tabs as well, main views. The first, as you see here, is the CAM view. The CAM view, or digital view, is what will show our digital view of our board and of our process later. The machining view is what the machine sees. It's where our placement will happen, and the later steps we can watch the fabrication happen as well. For now, we will start on the CAM view. The process will go through this main toolbar at the top left. We will start in the leftmost button and continue all the way down to the right. For now, we will start with the first button, the Process Planning Wizard. The first step, the Process Planning Wizard, is activated by this first button on the left of the main toolbar on the top left. It will open the Process Planning Wizard windows. Go ahead and follow the wizard in order to confirm the template choice. First, it will ask you the type of process. Are you doing a PCB, or are you making 2.5 degree elements? 2.5 degree elements are also known as divots or pockets. These are capable for this tool, but we are not doing them today in our process. So we will go ahead and process PCBs and hit next. The board that we're going to do if you are using the Hive's product is always going to be 2-layer. It is important to choose the 2-layer board because this has an automatic stop halfway through that will allow us to go and etch. It is important that we do not route the board out first, as the routed board can get caught in the laser and cause damage to it. So we must choose the 2-sided layer for our process. So go ahead and select Next. Third, it will ask you what kind of substrate we're using. Again, for the Hive substrate, we offer FR4 as our base material, base insulator, but there are many others that this can do as well, including Rogers, aluminum, and various types of plastics. Again, for our process, we will continue with the FR4 option and select Next. Fourth, it will ask you what type of through-hole plating equipment we're using. During a through-hole plating process, vias will be plated, meaning they will have copper added to them to allow for traces on one layer of copper to be connected to other layers of copper. We have two options for plating here at the Hive. The first, and far the most common, is the galvanic plating process using the contact RS style machine. This is a galvanic plating process, as I mentioned earlier, meaning it adds metal on top of metal, and it will plate everywhere on your substrate that is available to be plated. You may check that box if you are doing this process. We also have the LPKF Pro Conduct style of electroplating. This is not an electroplating process so much as it is simply a plating process. It is a more manual process that is designed for RF applications specifically. If you are interested in this process, please contact the Hive to get in touch with the other master PIs in the space for details on how to use this. In these videos, we will be using the galvanic plating process, so check the LPKF Contact RS box and then click Next. If you are not doing a through-hole plating process today, you will unselect both and select Next. Lastly, it will ask what type of surface finishing you are doing today. We will not be doing any in these videos. However, if you are, you can select either the LPKF Pro Mask for the solder mask application, the Pro Legend for the silkscreen application, or the Proto Print for stencil printing. For now, we will select none of these and select Next to see a summary of our work, and then hit Done. The second step is the Import step, and that is the second button in our toolbar. Importing associates Gerber files with layers in the software. Gerber files are not the only type of file this machine can take. They can also take DXF files, But we are not doing DXFs today, as DXFs are used primarily for the 2.5D elements. For now, you will import your Gerbers on a USB stick. Go ahead and you can insert it into the computer, and then you will locate them. For us, we will be making a board that we call the training board today. This board was fabricated in Eagle, which you can learn more about online. Eagle exports all of its Gerber files in a folder called CAM outputs, which then has 3 subdirectories: assembly for its assembly files and bill of materials, drills for all of the drill files, and then Gerbers for the aforementioned Gerber files. We will start with the drills file today and import the single drill file that Eagle exported for us. First, I always look at the viewing screen over here, just to make sure that all of the drill holes look right. Is this what I expect them to look like? If not, you can fiddle with the settings here on the right in order to get them so. And if that doesn't work, I recommend re-exporting them from Eagle entirely and trying the import process again. If it does look correct, go ahead and make sure the import column on the left is checked, and then look at the layer template button. This is the critical component of this step. You must tell the software which layer to place these drill files on. The drill files typically can go on the drill's plated layer, even if we are not doing a plated process. This is because the drill plated and the drill's unplated layers are done together in the unplated process. We will go ahead and select the drill's plated option. Once we have selected that, we can go ahead and add our Gerber files by going to the Add File button on the bottom left. Typically in Eagle, we can go up a main directory and back to our Gerbers file directory and select the 3 critical Gerber files that we'll need: the top layer of copper, the bottom layer of copper, and the profile or board outline Gerber files. Typically, Eagle will export many other Gerber files. You can mostly ignore these for a standard process. We will go ahead and select them all and click Open. The software has been programmed to automatically assign Eagle Gerber files to the correct layers, so you do not have to worry about assigning them to the proper layers. However, for those who are not using Eagle files, you will have to associate these Gerber files with their correct layers. The bottom copper layer will go to the bottom layer. The top layer of copper will go to the top layer. And the outline or profile Gerber will go to the board outline layer. Again, for Eagle, these are automatically assigned, so once you've assigned them, you may go ahead and click OK. And the board will import for you. If you would like to import a second board, the first step is to zoom out using the mouse wheel. You can also pan by clicking the mouse wheel and dragging around. We will use the left mouse button to select the entire board, and then the right button to bring up the context menu. Scroll down to Transform, and this will bring up the Transform window. In LPKF software, this means that we are in Transform mode. The Transform mode allows us to translate, rotate, scale, and mirror our board. To translate, simply left-click the board and drag away. To rotate, go to the Rotate tab and type in whatever you'd like. Say we want to rotate 90 degrees, and hit Enter. The board will rotate 90 degrees. It is an important and good idea at this step to look at your substrate and make sure that the orientation you want is the orientation that you have on this window. For later, you will not be able to change it. I will stick with this 90-degree orientation for now and hit Close. The reason to transform and move the board away is because the software will import the second board right at the origin, which means it will import right on top of your first board. So it's important to drag the first board out of the way and any subsequent boards out of the way before importing subsequent boards. If you accidentally import the second board on top of the first, you can Control-Z to remove all of the imported layers one by one. Be careful not to remove too many layers, however, because you can accidentally remove the first board as well by this method. If you would like to make copies of the same board, we can also do that. Select the entire board and right-click. Scroll down to Step and Repeat. This will offer a window that will allow you to array the board. If we wanted a 2x2 array, we would increase the repetition in the x and y direction by 2, or 2. And the distance, we would always add approximately 5 millimeters on it. Why do we add 5 millimeters? Because the contour router bit that will route out a board is a 2 millimeter bit. And 2 millimeters for each board will give us a small amount of gap between the boards that will allow the boards not to fall out. So I will set this to 20 and 28 and hit apply, and you can see the board has been nicely arrayed. Today we are only going to be making a single copy, so I can go ahead and hit Control-Z to undo any of the arraying. The next step is fiducials. Notice that we've skipped the third button, which is a rub-out step or an etching step. We do not do etching on the ProtoMat. The reason for that is that it burns through bits very quickly. So for now, we go on to the fiducials. You will click the button and click Fiducial. Do not click Create New Layer. That will confuse you later on in the process. We will click Fiducial, and it will open our fiducial mode. This window should not be touched. Instead, to create fiducials, simply click around the board. Notice that I do not click too far away from the board, like so, or right on the board, like so. If you create a fiducial on your board, it will create a drill hit in the middle of your board, which can probably be detrimental to its function. If you create a drill hit too far away, you're adding it to the space that you are needing to make your design. To remove these fiducials, we first have to hit Close, and then we can Control-Z to remove one, or you can highlight the fiducial you're looking to delete and click the Delete key. Also go away. Now, it is important to note you do not need fiducials around every board. Rather, you need fiducials around every design. So if you have many boards in one design, only put 4 fiducials around the corner of that design. After making the fiducials, the most important of steps occurs. We must save. You have to save here because the following step is going to be the toolpath generation. The ProtoMat has drills and contour bits as its tools. The etching machine, the Proto Laser, only has a laser. If you hand it a file that is telling it to use a drill bit, it will not know what to do, and you will not get anywhere. So we will go ahead and go to File, Save As. I like to save this file as what I call a pre-toolpath file, but how you save it is up to you. Once we have saved, we can continue on to toolpath generation. Toolpath generation is the 5th button. This will open up the technology dialog. The technology dialog has 3 main sections. The top section is your material settings, global process settings. These are just to confirm that your material type and copper thickness are correct. The next section, also known as isolating, is something we do not do because isolating is another word for etching, which is one of the things we do not do on this tool. So we go ahead and uncheck the process to not calculate any isolation toolpath. Finally, in the middle bottom, we have the contour routing. And this is where we can define how our tabs sit. Mechanical tabs are the bits of material that are left when routing in order to maintain the board's position while cutting the finished product. You can either do equidistant gaps around the board. You can do tabs on the corners, tabs on the sides, 2 tabs on the sides, tabs on the top and bottom, or no tabs at all. I strongly advise against using the no tabs option. The contour route will cause your board to spiral out of control at the end of the cut if you choose this option. I typically recommend 2 tabs for our smaller boards or 4 tabs for the larger board. The orientation of the tabs depends on your orientation of your board. Remember, we are going to be twisting the board out of our substrate at the very end to free it. So we want to know which of the two options we should choose. In this case, I want my tabs on the sides of the board so that I have more mechanical advantage while twisting. Once you've selected that, you can go ahead and click Start, and the machine will calculate how it will use the tools that it has to cut out and drill out the board that you've given it. You can click Show More to see more details of this if you'd like, but if you don't care, go ahead and just hit Close. After making your toolpath, I advise that you save here again. Do not file save, but rather save as, because we do not want to save over the pre-toolpath file that we so specifically saved earlier. I usually call this the post-toolpath file. The post-toolpath file can be used later if we want to replace the board while not ruining our opportunity to etch. The next step then is going to be checking our tool magazine for having the proper bits. That will be button 6, and you can go on the toolbar, and we can go ahead and click. This will bring up our tool magazine dialog. For our end users, the only section of this window that is important is the left one that says Required Tools. If there are all green check marks, go ahead and just click OK at the bottom. There is nothing more to do. If there are red X's in this section, go ahead and find a PI. The PI will help you change the tool bits necessary so that you can fabricate your board. Do not use the scroll wheel in the right-hand side of the window. It is extremely important because you can accidentally change the tool bits. If you do that, your board may be fabricated incorrectly. So go ahead. Since I see all green checks here, I will go ahead and simply click OK. The next step is what I call placement, or step 6.5. It is not a button. This is where we tell the software where we would like to fabricate the board on the substrate. Currently, the board is being fabricated right in the middle of this piece of copper. This may not be acceptable for some substrates. So we want to move that board somewhere else. Now, we want to first select our substrate. Today, I will be using a new sheet of copper. When you fabricate, we ask that you use used sheets of copper in order to use the most of the copper sheet that we can. You may use either the unplated or the plated substrates. These will both work equally well. There's very little difference between them, and you can plate even over already plated substrate. Go ahead and place your substrate onto the working table in the tool, and place the sheet into the middle of the working tray. The working tray is a negative pressure table that mostly adheres the sheet down onto the table itself. But to be safe, we strongly advise using our painter's tape here to tape down the substrate. This prevents the drill from getting caught and dragging the board around, for example, or some other unfortunate mechanical events from happening. Generally advise one piece of tape on each side, but this can change based on how used the board already is and to your substrate. Remember, the tape is cheap, but your time is not. So go ahead and use as much tape as you'd like. The main tool head here has 3 heads to it. The first, underneath, is the tool head itself. This is what holds the individual tool bits. The second is this aluminum can on the front. This is your camera. And the third, in the future, will be a dispenser. This is not assigned yet, but we will in the future. Once you are comfortable with the taping that you've done, go ahead and close the main cover again and return to the application window. We are going to use the camera today to locate an appropriate spot for our board to be fabricated. So go ahead and first we will select head and in the left-hand side here and select the camera. The button looks like a camera on a tripod. Next, we will go ahead and actually move the camera over to where we'd like to fabricate. Today, I'm going to fabricate on the left-hand side of the substrate towards the top. The mouse cursor button here allows you to move the head, but it does so in a rather unintuitive fashion, unfortunately. So, if the mouse cursor is enabled, like it is now, the tool head cannot move. You must disable mouse cursor first in order to move the tool head. Once we have disabled the mouse cursor, we can go ahead and move the head to where we want to focus. Single clicking is all that is required. Now, the next thing we'll want to do is actually focus the camera, and we can do that by the autofocus button. Focusing will occur automatically and will always occur between 17 and 23 millimeters. But it will never be 24 or 16. It will always be 0, 30, or in between there, so you will know that the camera is focused even if it doesn't look focused in the camera window. And as you can see, we're at approximately 20 millimeters, give or take, which means that I can be fairly confident that we are focused at this time. Because this is a fresh sheet of copper, I am okay with the position of the tool head and where it is in relation to my board. So I now want to move my board to where the tool head is. The first thing to do is to deselect mouse cursor again so that you do not accidentally move the head. Next, in the middle of the board, right click. Do not select the board or you will not find this option. You are looking for the button called Placement. This will bring up a placement window. Do not use this window to place your board. It will only confuse you. Drag it off to the side. Instead, left click and drag the board over to where your tool head is and release. Typically, I prefer to locate my board on the bottom left fiducial. If we zoom in on this board using the mouse wheel, we can see that the black outline is actually the outline around our design. It outlines the 4 fiducials. The board is much smaller. I can pan by clicking the mouse wheel, and then I will drag this board up so that where the tool head is approximately over that bottom left fiducial. Why do I want the bottom left fiducial? This is because the tool will look for that bottom left fiducial first. So it is a good practice to always find that bottom left fiducial when we are doing this. Once I am comfortable with this position, I will go ahead and perform what I call a walk around. The alternative way to move the head is actually using these buttons on the top left. The step size can be adjusted from 1,000 millimeters all the way down to 1,000th of a millimeter. Today, I will jump around in increments of 10 millimeters because that is normally a good option for this board, but your mileage may vary. Pan a little here to see the whole board, and then I will move around. What I'm looking for here is specifically any holes that might interfere with where my fiducial placement is. I do not care if there's holes in between my fiducials, only if there are holes nearby, because later that will affect the finding algorithm and whether it will find the correct fiducials appropriately. So I've jumped a little too far to the right here, so I'm going to drop my step size down to 5 millimeters and head back. This looks clean, as it should be, as this is a fresh sheet of copper. And we'll look up here. That looks good. Holes will be very obvious on this as well, because they will be very dark spots in a sea of very reflective copper. The other thing that we're looking for is cutouts. Cutouts of other boards that we may be near. Again, we want to utilize as much of this copper sheet as possible. So we want to place our designs as close as possible to other designs so that other people may utilize the same sheet. Fantastic. All 4 holes look approximately at good position and look to be free of other holes or malfunctions. So I may go ahead and close my placement window here and proceed to the final step, production. The final step, board production, can be instantiated in 2 ways. The first is the operate window down here. The operate pane, if you do the drop-down menu, will show you all of the various steps that will go on in this process in order. You can choose to select and start individual steps or start from individual steps in this window. There is also a process all button, and if it is on that, you can hit play to start your process. There are 3 buttons here. The leftmost button will play the current step that is selected in that dropdown. The middle button will process the current step that is selected and then continue. The final button is a stop button, and this will stop the processing at whatever step it is at. It is important to note that this button will wind down the current process. It will not cease the process. It will not stop immediately. If for whatever reason you need to stop the process instantaneously, you may lift the main cover to act as an emergency stop button. I caution you that this can be dangerous as it is a spinning tool, but occasionally this is necessary to stop further damage to the tool. I personally prefer GUIs, so I will select the 7th button, the board production wizard. Now, notice that this is not the last button. If you accidentally select the last button, you will get the tool library instead. Please do not mess around in this window. If you do, other people may not know and may get incorrect fabrication later. So go ahead and click cancel. The board production wizard is the 2nd to last button. This wizard will walk you through the steps necessary to fabricate the board. The first will ask you if you've mounted your material. We have, so we can go ahead and click Start. It will ask us about our material settings. Simply confirm that your material type and material thickness are correct. For the Hive's materials, the 1.51 millimeter thickness that is provided is approximately correct. Note that the drill will only go through 2 millimeters of substrate with the typical characteristics and parameters. Therefore, if your material is thicker than 2 millimeters, you must get a PI to help you with that process so that we can change the settings inside the tools. Please do not do this yourself. Once you have confirmed this top setting, you may ignore the entire bottom set of this window and simply click Continue. Next, a placement window will open up. Now, you may remember that the last step, step 6.5, was placement. The reason I do placement previously is that now, on the left-hand side, we can no longer select the head. And if we had not selected the camera head here, we would have to manually and approximately place our board, which may be detrimental to us in the future. Since I have already placed, I may click Continue. It will now ask me to save the document before beginning any future steps. This is not a save as step, so make doubly sure that you are currently in the post toolpath file. If you save over your pre-toolpath file now, you will be very sad when you get to the laser and you cannot actually do anything. I can look here and see that I am in the post toolpath, and I will go ahead and click Yes. The first steps that the tool will take is it will drill the fiducials. In order to do this, it must exchange the tool bit first and foremost. You should be on the lookout for this first machining operation, as it can indicate if there are issues with any of the settings in the tool. Once the tool has aligned and picked up the correct bit, it will then go ahead and begin a 2-minute warm-up process. This is an important step for the tool for the long-term maintenance and long-term health of the machine. We anticipate that these machines will last long beyond my time or your time here. So therefore, it is important not to skip these steps. The tool will drill out the corner fiducials first. Watch these steps, as it can also indicate if there is an internal setting incorrect. We are watching for things such as dragging of the tool bit or the tool bit catching on the material itself. Once these first two steps have been completed, you may then walk away and begin prepping for the laser etching process. On the left-hand side of the window, you can see the steps that are taken one by one. You may notice that the drill's plated is followed by the drill's unplated step. As I mentioned earlier, you may set the drill's file to the drill's plated step for this reason specifically. The board production wizard will reach the flip material stage about halfway through your production process. This is the step in which you should take out your material and move on to the proto laser for your etching stage. So, once we've reached here, we can lift our cover, remove the tape, and inspect the holes on our board. On the first side, the cuts are quite clean, but on the other side, we may notice that the cuts have burrs in it or other kinds of marks. So it's a good idea to grab a piece of Scotch-Brite or other kind of scour pad and lightly scour away those burr marks. This will improve our etching at the next stage. And then to be safe, we normally take a little bit of isopropyl alcohol and spray on both sides and dry with a lint-free cloth. The reason for this is to remove any remaining particles as well as remove oil that may cause the laser to refract unintentionally. Now that we have a clean board, we can place it into the proto laser.